Okay, so yesterday's thing, there is a small mistake in this diagram or in the concept. Can you figure out that mistake? Are the directions of the forces correct?
The centripetal force.
Yeah,
No.
centrifugal force, pseudo force.
It is along that plane,
Yes.
but we have taken as.
Yeah. So this thing, the direction is this one, FC, and there will be a component of that FC along that one.
This one.
So this is FC cos or sine along the plane.
Cos theta.
Cos theta. How do you know that?
In between the two lines, this theta only.
This angle is theta.
Huh.
Because theta is angle between the horizontal and the plane. So this horizontal only, and this is the plane. So those two lines are again, and this is vertical and normal to the plane. So angle between two perpendiculars is also theta, perpendiculars of these two lines. This vertical line is perpendicular to horizontal, and this normal is perpendicular to the plane. So these two are perpendicular lines, no? Got it?
Yes, sir.
See, one more thing is, say if I have two lines, make an angle theta, and if I rotate this triangle, or whatever you can say, these two sets of lines, this angle will be maintained, right? I'm just rotating
Yes,
it
sir.
as a rigid body. So I can rotate like this also until it becomes perpendicular.
Yes, sir.
Okay, so two lines, which is making angle theta. So if I take the new set of lines, set an angle alpha, okay, and this angle is also alpha because the full thing I'm rotating by alpha. So again, the angle between these two lines is the same theta. Okay.
Yes, sir.
So here this angle theta is between the horizontal and this plane. So if I rotate this folding by 90 degrees, I'll get this triangle. Okay. So this is FC cos theta, and this normal component will be FC sin theta. Okay, so here FC, instead of FC, I should put FC cos theta. And here it will be, yeah, around the plane only. So I'm just taking the cos theta component. So normal reaction, so the friction limiting force will be the normal reaction. So the normal reaction is also variable depending on the angle. No, weight component is also changing. So both weight component and the FC component will contribute to the normal reaction. So normal reaction is mg cos theta minus FC sin theta. Is that clear? Normal reaction is upward force, so it should equal to the other downward forces. So mg sin theta, mg cos theta is downward, and FC sin theta is upward. So that will go as minus. So mg cos theta minus FC sin theta. That is a normal reaction. Got it?
Yes, sir.
Okay. So this is yesterday's thing. So we'll move to the today's class 12.
So I sent you those problems in
Yeah.
by WhatsApp.
Actually, these are not difficult questions. I don't know why we not solved it. Okay. So so try this one. This is actually a trivial question. Your mic is off. Why is your mic going off? What the answer?
Electric flux over that curved surface will be 0, sir.
Why?
Because it is perpendicular, no?
No. Perpendicular means it will contribute. Only parallel will not contribute. Perpendicular means cutting through the surface, no?
No. That area vector and where is that electric field?
Whatever is the charge, it will field lines will go like this, right? So it is cutting through the surface.
Okay.
Only the field lines are going like this parallel, touching the surface or grazing the surface, then the flux will be 0. What the answer?
1 minute or so. Plane surface, say. Okay.
So this is Gauss law, no? The total flux coming out of this charge will be q by epsilon naught.
Come on. Yes, sir.
And that is passing through the curved surface and the plane surface. So 2 times the flux to the plane surface plus the flux to the curved surface is q by epsilon naught.
Yes, sir.
Okay, so now the flux to the plane surface of A. So this is the thing. Promise you'll get the answer. The total flux
Sir,
coming.
why did you take that flux through that curved surface as pi, sir? Pi is for entire flux,
No.
no?
If I is electric flux through the curved surface B.
Okay.
It's
Oh,
given
it
in the
is
question.
given in the question. Okay, sir. Yes, sir.
Okay, so correct option D. The question is not very clear here. It's some confusion is there. The electric flux in units of voltmeter. This is a little bit confusing. Okay, but this is the basic idea. This one,
So that is voltmeter only, no, sir?
what voltmeter? Flux is
EA, no, sir. For E, that is a volt per meter. Area is meter square. So
electric field is volt per meter into meter square.
meter square.
So
Voltmeter.
Oh, okay. I was thinking of voltmeter as an instrument. Okay, fine. Right. This one, two positive ions each carrying a charge Q are separated by distance B. This is also a trivial question.
Shit.
Got it?
Yes, sir.
What is the correct option?
C only, sir. Yes.
Yeah. So can you check the answer? Answer key.
Question number, sir.
Looks like 34.
C only, sir.
Okay, what about this one? 44.
54. D only, sir.
Okay, fine. So why you couldn't do these questions? These are not difficult ones. You didn't try properly.
I forgot that Q equal to NE.
Okay.
And previous time I didn't read that question properly, sir.
Yeah, this is Gauss law. The flux coming out of a surface, closed surface, is the charge inside by epsilon naught. This is Gauss law. This you know, right?
Yes, sir.
Gauss law. And Gauss law, this flux is over the closed surface. So I can split that surface into phases. So the curved face plus the two phases. And one assumption is the charge is present in the center. Only then the flux through these two phases will be equal. Only when they are two equal, I can write as 2 times one of them. Okay,
Yes, sir.
that is an assumption which is not mentioned in the question. The hollow center of charge Q is placed within it if phi is flux in then the flux length. Yeah, suppose the charge is not in the center, it's somewhere in the here, then I cannot find this thing as half of the total coming out of the two. Okay, so the assumption is it's placed at the center. Only when the
Yes,
flux
sir.
through both the plane phases are same, so I can write it as 2 times plane phase. If the charge is placed somewhere else, I can get the sum of flux through both A and C. So the sum of flux through both A and C is Q epsilon minus 5, only the numerator. But individually, if I want to find, I have to make the assumption that's placed at the center. Then it is half of the total coming out of the plane surface. Is it clear?
Yes. Yes, sir.
This one, this is very trivial. ABC are 3 points. Theoretical question. So what is the answer?
I don't know, sir.
No, how
Electric
you,
potential.
what is the rule for joining drawing the flux lines? See how you decide the density of lines, how close the line should be.
That electric flux only, sir.
Yeah, so if E is more means, so you have to set a scale, like while drawing a scale in your lower classes, say 10 standard or something, you know, in the x-axis you have put a scale, no, 1 centimeter equal to something, say 5 meters or something. So once you set the scale, you have to be consistent with that. Like x
Yes,
scale.
sir.
So similarly here, the scale is like 5 lines for 1 volt per meter. So something like that, you have to put a scale. Okay, so if the electric field is 1.1, then it should be something more than this one. Okay, or if the electric field is 2 volt per meter, the number of lines per unit area should be 10 lines. Is that clear? And suppose this is the unit area. Okay, and if the electric flux, electric field at this point is 1 mole per meter, say I'm putting a scale of 3, and if somewhere else the electric field is 2 volt per meter, then the number of electric fields causing this thing should be 6. Okay.
Yes, sir.
So here, if we draw a unit area here, draw a unit area here, and draw a unit area here, is the number of lines crossing this surface same?
No, sir.
No, actually it is same, because the thing is, it's, see, you have put the line here. Instead of that, I can draw 3 lines here also. Okay. What makes sense is the density of lines. I'll repeat. See the density of lines. See at this point, see I can draw any number of lines, no, but just the spacing should be same. The thing is, the electric field here, it's uniform everywhere, because the density of lines at any point, if you take lines like this, okay, then it is same. It is just a representation. So the density of doesn't mean that I have to actually sit on the line to cut the line. Suppose here I've drawn 3 lines. No, suppose you change the scale 10 times. Okay, then I'll draw 10 more lines here. I can change the scale, no, but I just have to remember the scale, what the scale is. So now suppose I will draw 3 lines like this, then the density number of lines cutting through A, B, and C are same.
Okay, so they have equal potential also.
No, number of lines. To find electric field at point A, you have to draw a unit area. Okay, and then find the number of lines passing through this point A, or the area at A. Okay, so see, for in the x-axis, I can draw divisions like this, right? Suppose I want to find the distance. See, from here to here, this is 2 divisions, no?
Yes, sir.
So it's the same 2 divisions. How do I draw it? Actually, okay, here there are actually 3 lines are there, no? 2 divisions, but there are 3 lines. Yes, in this range. Yes or no?
Yes, sir.
Okay, so similarly, I can draw the same 2 divisions length, but here only 2 lines are passing, but still the length is same, right?
Yes, sir.
So it's a similar concept is here. The density of lines passing through. See, that's what I'm saying. Here they're on 3 lines. No, I can draw the same thing, on a finer scale. Like if I have 1 divisions for 1 mm, I can also draw divisions for 0.1 mm. So that way the number of lines will go 10 times. So in that case, then the number of lines passing through A, B, and C will be same.
Okay.
Okay, you think about it after the class. It's actually a trivial thing. So in between 2 lines, I can draw 10 more lines. Okay, with the understanding that 1 division will be 10 times 1 by 10th of the previous unit. Okay, so when I draw these fine lines, then the number of lines passing through A, B, and C will be same for the same area.
Yes, sir.
Okay, so that means you can check the answer. You understood this one? This is a better way of understanding the problem. I can always draw finer lines, okay, without affecting the physics of the problem. So now when I draw finer lines, the scale will change. Okay, so when I draw finer lines like this, then you can figure out that. And the finer lines means, say, between these 2 lines, I should draw the equal number of finer lines. Suppose if you choose a scale such that between these 2 existing lines, I draw 10 more lines. The distance between these 2 lines here at point is also same, no? So the number of finer lines passing through A, and number of finer lines passing through C, number of finer lines passing through B are same. Is that clear?
Okay, sir.
Okay, your volume is low. Fine. So did you check the answer? Answer is correct.
Option B, sir.
B, that's not correct, no? Yeah, your volume is low.
Option D, sir.
Option D. Then they have not understood the question. No, this cannot be because maybe they have made a mistake. Maximum at B. No, it's not correct. Because this is a picture of a uniform electric field. You can actually check with some other resource, NEET 2013, right? Or I'll check and let you know next time. NEET 2013 question. So according to me, the correct answer is this thing, B. Okay, this is yes done by mistake of not understanding the question. Okay, if you think in terms of the definition as a verbal thing, that's the thing. But if you understand the definition properly, then it's same at A, B, and C. See, whenever it is uniform electric field, the picture will be like this. If you take capacitor plate, The electric field between the capacitor plates is like this, no? Parallel lines.
Yes, sir.
And between the two capacitors plates, the electric field is constant at any point. Yes?
Yes, sir.
Okay, this is like a electric field between two capacitor plates. Okay, this one, three constant experimental shells have. Why is your volume low?
Sir, I connected to my headset volume, sir. Bluetooth
Headset,
volume.
headset on
Yes,
laptop.
sir. No, on phone, sir. My laptop started restarting, so I joined to phone.
Okay, my level is also going down. Oof. Okay, this question, try this one. Three constant experimental shells and sufficiencies. Okay, this is also a trivial question. Okay.
All three not equal, sir. Option B. We have to calculate potential on that shell only, no, sir, not inside or at a distance.
Check the answer.
Like this one, option B, sir.
BC equal to B. Okay. Oh, sorry, it's minus sigma, no? Uh, okay, so this is okay. So the potential is Q by R, no? For a spherical, yeah, electric field is Q by R square. So potential is Q by R. So the potential for the first one is Q by A, QB by B, and this one, and this QA is 4 pi R square sigma. So it is A square. So it goes as A, B, and C. Okay, and this sigma minus sigma, and this one. Then simply it is B minus VB.
The potential, uh, yeah, A also experience potential due to B shell and C shell also, no, sir.
Oh, yeah. It is just-
Uniform potential of K2 by capital L inside the shell.
Okay. So I think Yeah, the best easier way is to see here the electric field will be like this in this direction. Here the electric field will be like this. Okay, the outside electric field will be yes, positive, right? Outside will be electric field. Okay, so to find potential at point A, I have to find potential due to this one plus potential due to this B and the potential due to this. Okay, inside the potential will be same as the potential. Okay, fine. So yeah, so potential at point A, point B, you have to find out. Can you do it?
Okay, I have to take a fixed point or I have to find that potential on the shell. That alone so.
Okay, I'll just tell the method. So VA is potential due to this one. So it's QA by
VA is on that A shell, sir.
yeah, VA is on the first shell.
Okay, on that shell. Okay.
So it's QA by A plus the potential at this point because there is no potential difference from here to here. Inside a charge shell,
Yes,
okay, the for outside points it's as if the point charge is located in the center, and for inside points it's as if the there is no potential difference from this circle because inside the electric field is zero. So for the potential due to this B at point A is same as potential due to B at this one. That is QB by B plus QC by C. QC is charge on C. Okay, similarly, VB, it's QA by B okay
plus QB.
plus QB by B and QC by C. At point B, the potential it's due to this inner one, it's as if the point charge is located here and the distance of the point charge, so it's by B. And due to this second B, it's QB by B, and due to C, it is same as the thing on the surface. Similarly, PC is QA by C plus QB by C plus QC by C. Okay, and QA is sigma into E square. QA is sigma into E square. Constant of proportionality is there, that you can forget. B is minus sigma into B square, and then QC is sigma into C square. Okay, so if you use that, you get B as sigma A minus sigma B plus sigma C. PB is
So all are different only, no, sir.
no, have you done it properly? And this one is QA is sigma A square by B minus sigma B. QC is sigma C. And then BC is QA is sigma A square by C. QB is minus sigma B square by C. plus sigma c. So you have to BC. And he has given the relation that A plus B is C. Where is A plus B? The correct option is option D, is it?
But all are different combinations.
No, what is the correct option is given?
Option D.
D. D, is it?
Yes, sir.
Is it D?
Yes, sir.
Okay, I'll tell you later. So this is the method. So I'll come back to this later. So this one, electric potential at a point A on a free space due to charge Q is this one. Electric potential. Okay, the electric field. I don't know how this is trivial, no? Electric field at a point due to charge Q. This one. The electric field is, how is electric field related to?
V by R.
So actually it depends on the gradient of potential, but he has given this the potential, no. So I have to find out how the this question is also not complete. Electric potential at a point in free space. If you assume it's point charge, then we can do something. V is Q into 10 raised to 11. Okay, and E is gradient of negative gradient. Question doesn't seem to be correct. What is the answer he has given?
43 lakhs.
Which option?
C, sir.
C, okay. This question doesn't seem to be correct because we should know how the voltage is changing. We just see to find slope of a curve. Okay, we should know how the curve is changing. Not the value at one point. Just using the value at one point, we cannot find the slope. We have to know how it's changing in the neighboring points also. So the electric potential at a point is this value. So with that, we cannot find electric field. We have to know how the potential is changing in the neighboring points.
At that point only they are asking,
Okay, leave this question. I'll come to it later. A bullet of mass 2 grams having a charge of 2 micron, then what is the potential difference? Must be accelerated from rest. Oh, this is a trivial question. Got the answer?
Okay, I have to use it, but okay.
You have to speak loudly.
Yes, sir, I used to reiterate that kinetic energy is achieved by the.
No, your voice is not out clear. It's very low. Or you try to run on the laptop?
It was restarting, sir. That's why I joined to the phone. Now can you hear me?
Yeah. So what is the answer?
Fifty kilowatts.
Is that correct? Check the option.
Yes, sir.
Okay. So this is the basic relation. So what is this? What is this relation called?
Don't know, sir.
Work energy theorem, right? The gain in the kinetic energy, okay, it's equal to the work done on the charge, okay,
Okay.
or the work done by the electric field on the charge. So work done on the charge is Q into V. If a charge passes through a potential difference of V, then the work done by the field is Q into V. That you know, right?
Yes, sir.
Okay, so that should be equal to gone in the increasing the kinetic energy. So this is work energy theorem. Work done has gone in increasing the energy. This one, oh, this we already done.
Yes, sir.
This one,
I don't know.
what is the answer? You know how to do it?
C, sir.
B.
C, C.
Check the answer.
C only, sir.
Okay, how did you do it?
No, sir, I don't know. That's why I sent it.
No, how did you do it?
Sorry, I didn't get it. What?
I can't hear you.
Option C, they are given.
No, no, how? Did you find this answer?
No, sir. I don't
No.
even know how to proceed.
Okay, see, uh, you have to take a small element here. Okay, so the electric field due to this element will be in this direction, right?
Yes, sir.
Because away from a electric field due to the point charge is away from the point charge. If you take a small element, it's like a point charge. So, and I have to take the corresponding element here. Okay, so if this element is at an angle alpha, the same element I have to take same angle alpha. Okay, I'll take pair of elements. So the electric field due to this element will be same magnitude, right?
Yes, sir.
By symmetry is the same thing. So what is the sum of these two electric fields?
2D cos theta.
Yeah, so only these component will add. The perpendicular component will cancel.
Yes, sir.
Okay, so it will be 2 dE. I'll take this angle as theta. So this angle is also theta. So cos theta. Is that right?
Yes, sir.
And dE is lambda into r d theta. Is that clear? This is d. Sorry, this divided by the distance square. D is q by r square, no?
Yes, sir.
And then the constant of
Okay.
proportionality is there, k, which is 1 by 4 pi epsilon naught. So kq by r square. So now r is constant. So the only variable is theta. So I have to indicate this thing from theta equal to what to what?
0 to pi, sir.
Integral cos theta d theta integral 0 to
Pi.
pi by 2 because I'm taking pair of elements. No, so if I cover from here to here, I'll cover this full semicircle.
Okay.
I'm taking pair. No, so when I cover quarter, I'll cover both of them. So when I go from here to here, so cos theta, integral cos theta from 0 to pi by 2 is 1, right? The standard result will be sine theta, and yes, this is 1. So answer is 2k lambda by this thing, and k is 1 by 4 pi epsilon naught. So it's lambda by r into 1 by 2 pi epsilon naught. R is actually A, the radius of this thing. So I have taken the contribution of this semicircle, right? What is the contribution of the line?
2k lambda by A.
No, this.
Lambda by R.
So R is A, right?
Okay.
Yes.
Yes, sir, but due to line that will be 2k lambda by R now, sir.
See, due to this line, if you take an element here, the electric field with the element will be this way, right? And if you take it corresponding pair of element here, the electric field at this point will be like this, so it will cancel. So the electric field due to the straight line at this center point is 0.
Okay, at that point. Okay.
We are finding it more, no?
Okay, sir. Okay.
And also we have a standard result of this electric field due to the wire at a distance A, right? So that will go as R, I think, proportional to R. If you take Gaussian surface here, okay, so the flux coming to the surface is the electric field into the surface area, that is 2 pi R L, that should be equal to the charge inside 2N. So the electric field is going as 1 by R. Okay, there is a problem here. Actually, with this logic it works, but this logic, if you get closer and closer, it will work because this is the center, no. But here this is infinite wire. This is not infinite; it's a finite wire. Yeah, this is not applicable here. This is for finite infinite wire. Yeah, this using this Gauss's law and in getting the electric field is 1 by R. This is true for infinite wire. Is it correct? Is it correct? Is it clear? Okay, so that I don't have to use here, so I can just use this simple logic. I'll take again pair of elements. There's electric field at the top one will be bottom towards bottom or downwards. Electric field at the bottom element the bottom will be upwards. Those two are equal, they will cancel. So all the pair of elements will cancel. So electric field is finite, wire at the center is 0. So only this curved thing will contribute. That is this one. So it's a simple integration.
Yes, sir.
This one. This also we have done. What is the answer?
I want to use
Speak loudly.
option D.
D.
D, sir. D.
B.
D, sir. Option D.
Okay.
Fourth option.
Okay. How come there is increase in energy?
Sorry. Option D, sir. Sorry.
B.
Yes, sir. Second option.
Yeah, it makes sense because see, after connecting the total energy is U by 2, right? Initial energy is U and the final energy is U by 2. Where did the energy go? Energy loss happened. If you use energy conservation, initial energy is U, final energy is U by 4 plus U by 4. So it's U by 2. So there is loss of energy, right?
Yes, sir.
Okay, that I will tell you why there is loss of energy and how do you get this answer. Try to solve it. So this is the initial condition. The thing will charge it to V. So the final thing is two capacitors, same capacitance value. So in this final situation, so what will be the potential drop across this capacitor? Is it V?
Yes, sir.
Oh, no, why will it be V? It will be some other different voltage. But across these two will be same, V1 and V1.
Same, sir. Okay.
V is the initially it's connected to a battery. Okay, so it will have some potential, let the potential be V. And after the final thing, I'm connecting one more thing in parallel. So the potential will change. So what will not change from here to here? That is the charge. Suppose the initial charge is Q, and here will be Q by 2, Q by 2. Because it's symmetry. So whatever is happening here will happen here. So the charge will be split into two equal halves. Okay, so energy you can write in terms of Q square by 2C. Final energy is Q by 2 square by 2C. Actually, it's half is there, half factor is there.
No, sir.
Okay.
Q square by 2C only. That's right. That is for half C
Okay,
square.
into 2. So here the 2, then 2 will cancel. Okay, so
Why have we included half there? No half included.
right,
Q
right,
square
right. Okay, fine. Already half is there in the 2C. Okay, now you got the answer. This 2 is there because there are two capacitors.
Okay, sir. But in terms of V means how can I do that for half?
You have to find V then. You don't know V1, right?
That one.
So don't do that because initial thing is known in terms of charges. So initial charge and final charge are related by Q by 2. Okay, so it's easier to use Q square by 2C. V means you don't know V1. What is changing, what is not changing from initial to final is the total charge by charge conservation.
That V is Q by 3 now, sir. So Q by 2C. V1.
V1, yeah,
V1.
V1 is half. So V1 is Q by C. Yeah, it's V by 2 then.
So half C square.
So V1 is V by 2.
Yes, sir.
So this also you can write as half C V square, and then it will become half C V by 2 whole square. So this also gives me the answer.
Yes, sir.
Half C V square. So again, it goes down by half. Got it?
Yes, sir.
So you find the total energy is going by half. So the individual it will go by 1 by 4.
Okay, individual means we have to divide it by 2. Okay.
Yeah, with each capacitor, no?
Okay, if there are 3 means we have to divide by 3 also.
Yes.
Okay.
No, then it will again change. It will become Q by 3. Okay.
Yes, sir.
So it will become 1 by 9. So 1 by 9 into 1 by 3. So I think again it will go as 1. Yeah, the logic is same. So in that case, it will be Q by 3, Q by 3, Q by 3.
Okay.
Okay.
Yes, sir. So charge divides based on that the capacitance only. Okay.
Charge is total charge is not changed from here to here. And since the capacitors are same,
If
okay,
suppose C and 2C are joined in parallel,
no, then will be
how will
complicated. Then you have to take this charge as Q1, this charge as Q2, and Q1 plus Q2 is capital Q. Okay, so and then you have to equate the potentials. So Q1 by
Yes,
C equal to Q2 by 2C. So Q2 by Q1 will be ratio of half or something. So you have two equations and two unknowns. You have to solve for Q1 and Q2, and then it can be solved.
yes, sir.
This one, this is a theoretical question, no calculation. Check the answer.
69. Yes, sir.
Understood?
No, sir.
See, if you're doing work on the system, work done on system means energy of the system will
PH12.
increase,
Yes, sir.
because if the system is doing work, it will lose energy, right?
Yes, sir.
So to bring two electrons closer, we have to do work on the system, right?
Yes, sir.
Because there will be a repulsive force.
Um,
So external agent has to do some work to bring one electron towards the other electron. So work is done by on the system by some external force. So whenever you do work on the system, okay, the energy of the system will go up.
Sir, what if that the proton is bring toward the electron?
What?
What if a proton is brought near the electron?
Then the energy will go down because you don't have to do any work. Electron
Uh,
and a proton.
sorry, same only, no, sir.
So then the energy will go down.
Why, sir? There is attractive force, so then we don't have to do work.
See, then in that case, whatever is the electric field here, okay, so that is the thing that's pulling this proton towards this one. Okay, so the work is done by the electric field. Electric field is part of the system. Electron for the system. So work is done by the system.
Okay, thank you.
So it lose energy. So in the extreme case, this electron proton goes and joins with this electron. The net charge is zero, right? If you look at the full thing.
Yes, sir.
Okay. So in that case, the electric field everywhere is zero. Initially, there was electric field which has some electric field has got some energy. Whenever there is electric field on space, there is some energy in that space. Okay, so when this proton goes and joins with this electron, the electric field everywhere is zero. So there is loss of energy. So the system is losing energy. Then the extreme case. So the energy of the system, when the proton is moving towards the electron and joining with it, final energy is zero. Initially, there is some energy because there is some electric field. Finally, it is becoming zero. But here, the electron goes and say merges with the electron, it will be 2e, and there will be electric field everywhere here.
Yes, sir.
Okay,
And the energy can't be negative, no, sir.
it can be negative. What makes sense is energy difference.
Okay,
Energy
okay,
can be positive or negative depending on the reference. Okay, especially for potential energy, we can choose an arbitrary uh, reference point. So when you're choosing arbitrary reference point, the energy can be negative. What makes is the energy difference.
okay, sir.
Okay, a particular mass sum and charge Q is placed at rest in a uniform electric field. Okay, point charge is 40 capital x axis. Okay, this is also a trivial question. What is the answer?
I don't know, sir.
This is x equal to 0. This is a, and this is 2a. Okay, so 4q is here, minus q, and then 4q. Okay, then minus q. Is it in stable equilibrium? So stable equilibrium means I just have to move this minus q in some small direction and then see whether it will come back to the original position. So suppose I move this thing this way, the attractive
They
force
didn't mention about this
due to
electric
this will
motion.
increase. So it will continue to move this way. So option 1 is not, E is not true. All charges are in stable equilibrium. That's not true because E is not true. All charges are in unstable equilibrium. Okay, this 4q, there will be repulsive force from here and attractive force from here. So move towards this one, the attractive force will increase and the repulsive force will also increase. None of the charges are in equilibrium. So this minus q is in equilibrium because it's equally attractive on both the sides of. But suppose if we take this 4q, the force acting on this 4q by this repulsive force is 4q square by the distance square, that is 2e square, and this attractive force is 4q square by the distance square is e square. So these two are equal. So 4q is in equilibrium, but whether it's stable or unstable, you have to find out. So this thing, if I move towards this one, the repulsive force due to this will increase, and the attractive force due to this will also increase. Option D is also not true. All are in equilibrium, but the thing is it's not stable equilibrium. So check the answer. Is it option C?
Yes, sir.
Yeah. First thing is all the charges are in equilibrium. Equilibrium means the net force is zero. Suppose you take this minus q at center, it's in equilibrium, right? Because the force due to 4q on either side is equally attractive, so they'll cancel. And the fourth one is 4q. Due to these two is due to this 4q, the repulsive force of 4q square divided by the distance square, that's 2e square. And due to this minus q, the attractive force of 4 into q square divided by the distance e square. So here 4 square and this 1 4 will cancel. So these two forces are equal. So the charge 4q is also in equilibrium. But whether they are in stable equilibrium or unstable equilibrium, that you have to find out. Minus q is in unstable equilibrium because if we move q a little bit towards left, the attractive force due to this left 4q will increase and the attractive force due to this right 4q will decrease. So it will continue to move towards left. So this is minus q unstable equilibrium. So from that I can eliminate the options. Only minus q is in stable equilibrium. That's not true. Minus q is in unstable equilibrium. Option E is gone. All charges in stable equilibrium. Option A is wrong, so option B is also wrong. And none of the charges are in equilibrium. That's not true. All are in equilibrium, but they are unstable equilibrium. So all charges are unstable equilibrium. So option C is the only option.
So
Is it
4Q
clear?
also unstable equilibrium.
Yeah, all are unstable equilibrium. And all the charges are in equilibrium.
Okay.
Equilibrium in the sense the net force is zero. Unstable equilibrium is from that equilibrium position, if a little bit disturb it, it will lose its equilibrium. It will not come back to its original position.
So how will that 4Q move if I move towards the left way?
No, speak loudly.
How will that 4Q charge move if I move it by distance of A by 2?
I can't hear you.
Sir, how will that third charge move if I move the third charge by distance of A by 2 towards left?
Not distance of A by 2 and all. You just have to distribute very little by distance
Okay.
dx. Okay, so that you have to figure out because this 4q, if I move towards little towards left, the attractive force due to this will increase, and this repulsive
Repulsive
force.
force also increased. No, sir.
Okay, that's what I'm saying. I can eliminate A, B, and D without any doubt,
Okay.
because
Okay, sir.
so that's why I'm saying it's C.
Okay,
Okay,
sir.
this right charge I'm not sure, because if I move a little bit towards this thing, the repulsive force due to this will increase and attractive force due to this also will increase. So both are increasing. It's possible that it might come back. But the thing is, amount by which it's decreasing, that I have to figure out, because it's 1 by r square, no? So the rate of see the rate at which the attractive force is increasing and the rate at which the repulsive force is increasing, they are not same. If they are same,
Okay.
it will come back. They are not same because this is plot of
Distance between them and the two.
it's 1 by r square, no?
Yes, sir.
Okay, so at a smaller distance for the same delta r, the change in the force is different, because here from here the r is different and from here the r is different. So the little bit disturbance, the increase in the attractive force will be more compared to the increase in the repulsive force. So there is an imbalance. So it will be an unstable equilibrium only.
Yes, sir.
Okay, so it will move towards attractive force will dominate, because lower R, the change in delta is more compared to higher R. So it will move towards left. So it is unstable only.
Okay, sir.
This one, there is an electric field. This is also a trivial basic question only. Can you get the answer?
Twenty Newton per kilo.
Check the answer.
Okay. Question number 2. Yes, sir. Option B only.
Okay, this is how it did, right? Work done.
Yes,
That's
sir.
the electric field, the component will come. And this work done has been given as 4 Joule.
No, I didn't take integration. It's straightly Q cos theta. Yeah, into distance.
Got it?
Yes, sir.
Volt per meter, same as Newton per coulomb. This one,
It's not complete, sir. I have sent you a diagram also. No.
got the answer? I think it's a little bit complicated.
I don't get you. Why did you take that separation as y by tan alpha, sir?
Uh, okay, so initially, okay, let the length of the string be L. So there are two forces and T cos towards right, and there will be a force of repulsion. So this equation is clear.
That distance separation between them is r1 in sir. Why did you take that as y by tan alpha?
Yeah, R. Okay, it's given as R, is it? Okay. Now the strings are rigidly clamped with the equivalent position between the two points. Okay. Oh, this is given as R, is it? So R by 2. Right, you can take it as R only. And see, this is tan alpha is y divided by this distance, no? So this
Yes,
distance
sir.
is y by tan alpha. So R is
Yes, sir.
twice y by tan alpha. Okay. So this you can write as R only.
Into r square only.
This is tan alpha. And this, so actually tan alpha is y
Y
divided
by
by R by 2.
r by 2. Yes, sir.
Okay. In the second case, so actually I think this L1, so this is exactly same for this one. No is anything anymore. No. So in the second case, the same thing, tan beta will become mg by q square into the r1 square. Okay, and we have to find r1,
Yes, sir.
right? So, and tan beta is the same thing. It will go as y divided by y by 2. Tan beta is y by 2 divided by r1 by 2. Okay, so now we find uh, so from this I can get the answer. I think. So it's y by r1. This one. Here it is 2 times y by r this one. So it's given as q. So now if I divide these two, I'll get
Sir, I think r cube by root cube of cube root of 2. You can divide that one, no, sir.
if I divide this thing, I'll get cube. No.
No, sir.
So this r will go here, so it'll become r cube. No.
Ah, we have to take the tan alpha, that both options, tan alpha by tan beta. If you divide that one, you will
Yeah,
get
if I
the
divide these two, what will get?
r by root cube root of 2, sir. r1s.
Right, just let me try that one. So if I divide this by this, I'll get no r1 cube. No. R cube. 1 by 2. Yes. Clear?
Yes, sir.
Okay, we'll close now. So you have to revise.
Okay.
Otherwise, it will be a problem. Otherwise, there's no point in learning because you'll forget. And you have to revise the very next day. So tomorrow I'll do class 11. Okay,
Okay.
circular motion. So you have to revise this video then.
Yes, sir.
So this one, and I created the timestamps. Okay,
Yes, sir.
so when you're revising, you just go through, and you can also create your own comment, and then whatever notes you want to take, you can write in the comments. Whatever is not clear for you, you can write it here itself. You have
Okay, sir.
your own comment, right? So questions not clear, and then you can just mention the timestamp 25. Say suppose the time is like this, 14. Okay, and if you say comment,
Yes, sir.
there is a see the comment is here, and then you can remove the comment after some time. You can delete it.
Okay.
Delete it. Okay, so you don't have to take a note separately. Just in
Yes.
the comment section, you just write your notes. Okay, and then you can delete it later.
Okay, sir.
And for creating times, you just have to type as 25 colon 14. It will automatically go to the timestamp 25 14. Okay,
Yes, sir.
and then you can delete the comment later after 2 or 3 days. Okay, see you tomorrow.
Bye, sir.
Bye.